Okay, we will come back to the stage again. So we continue from yesterday, the routing working group, the readout. So there's one place we continue from this slide. So yesterday we said we have one during the Phoenix Wing project initiative. We have like say the one code get merged into the FR, which is adding the PIC support, the perfect independent convergence support, but later on get it back out. And we want to see the why that the main reason is that FR is a concern to say, hey, Zebra is already complex because this is our RIB that to deal with the forwarding decisions. Then what we do is more like say this is based on the SONiC hardware capability because this is the hard size support. Then they say, why not you do it on the URD pad? So that's the main reason. That's why the recommendation is like I say, don't put all the complexity into the FR. Let's divide and conquer it. Separate as a RIB and FIB. So that's where introducing the RIB and the FIB concept into the SONiC. So I'll let the Patrice continue to talking about, like say, what we saw process on the RIB and FIB.
All right. So first, good morning, guys. Thanks for Google for hosting this event. It's quite cool, actually. All right, so actually it's kind of cool because the way like Eddie's mentioning it was really tough for us as a work group to get where we were. Like even though that that RIB and FIB exists on pretty much all the NAS, and it's kind of obvious, it was not for us because well you have this whole history and there were 3 problem statements coming at us that we were trying to fix them like kind of in each of them like in parallel. So, and then we realized last year that say, shoot, what are we doing? Like, if we just need to step back and say, okay, what are the principles in routing? Then you need a RIB and a FIB. So this is a bit like how that happens. All right, sorry. Okay, cool. So as you can see here on this picture, well, on the left side is what everyone knows, or pretty much everyone in routing or building in this world. Whereas on the right side, this is what SONiC is proposing. And where I am putting the question mark is because today the RIB FIB is kind of all bundled into a single piece of code within the FR routing, the Zebra portion, right? And then as soon as you try to optimize this, well, you're kind of stuck inside that BGP container. And SONiC will do his own job based on some flat or data that's come from FR routing. So this is where we want to strike like completely and fix the problem. The other challenge also that we've got with that is then we have 2 communities also to sync up. So it's kind of, this is where it's getting more interesting. So if you look at it, well, little principle for people who are not running expert here in this room. So the RIB, what it's going to do, will take all the information from multiple protocols and build the best path, right? And then download that to the SONiC side, where we're going to have now a FIB manager, where we will translate that into proper forwarding objects. Okay, that's the basic concept we were trying to do here. So now the first thing that we were working like, it's actually been almost 2 years, is the next subgroup ID, right? Mm-hmm. So basically creating a level of indirection, allowing us to, instead of downloading, I will say millions of routes, I hope, mm-hmm. with next up information or path list, then these millions of routes are going to point to a single, or hopefully a single next subgroup ID, which is your level of indirection. So therefore, if your path list underneath is changing, then you can just update that next subgroup information. So it's a single update coming from down to up to down, and you don't need to reapply a million of information into your forwarding path. Okay, so there was like approach doing on that. There was a lot of work done also by the FR routing community, thanks to these guys, because we beat them up a bit. And so the next subgroup ID now is getting much better. Is getting consistent. They are not always changing. So this is they've done an amazing job there. But at the same time, the second problem statement is how do we build the BGP PIC? Because BGP PIC is quite important for all of us. If you want to start using it as a router, because your convergence will be great, especially if you are doing edge or core, and even fast reroute in the future that we are hoping to bring very soon. So then you need to, and then you realize that, oh, I have an extra group ID, I have my PIC, and they are flooding in information. They are not always using the next subgroup ID. So this is where we're starting to realize that, oh, we need to combine these programs together. And lastly, with Eddie, the SRv6 stuff, right? So you have like other type of information on top of all of this, which is SRv6 specific or VPN specific that needs to also fit into that picture. So then this was a bit like the puzzle that we start playing with.
This is basically we break in the previously the FR assumption. Previous assumption is like say, whatever the kernel forwarding chain will be the same as SONiC forwarding chain. Now we're breaking it. So
Exactly.
it's introducing the complexity.
So like today, if you look at the forwarding chain, they are flattening, or they are the Linux kernel friendly. Right?
Yeah.
So it's full flattened with a hash. They take the path list, they hash it, they give it to the kernel. They send down the same information to the FPM-SIGD, or actually the kernel is doing it, right? So then we are changing that game where what we're going to be doing is most likely creating a block or a module in the context of the FPM-SIGD that will get new updates using next subgroup ID, not flattened anymore, into the SONiC. And this is where we're going to start using it so we can achieve the 3 power segment I just mentioned before. So, right?
Yeah. So here,
all right. So for the benefit, well, I mean, obviously we are trying to have like very clear separation from data plane and control plane. So especially with the FR routing that they are living in their own world, I will say, right? They are meant perhaps for something else, sometimes not on the SONiC. So want to make sure that we have a better separation there. And then also like if you can create the proper forwarding chain, so you will have much better, most likely scalability and convergence and speed whenever failures and recovery happens. Give us more flexibility on the SONiC side as well for programming your forwarding chain, and debugging obviously would become easier. So that's all the benefit. Whoops.
Yeah. So then we'll basically say how we handling it, right? So if you're looking at the previous slide, I probably like go back to this one. So what we want to do is like we want to introduce in the FIB, but I don't want to introduce it as the FIB manager as a separate process. So we already have quite a lot of processes there. So we want to put it as a block into the FPM-SIGD. But today FPM-SIGD is very dumb, just the pass-through pipe doesn't have any intelligence. Now we want to give a little bit of intelligence, which we can add converting the RIB object to the FIB object. So that's the main goal. So for doing that, but I don't want to do the whole FIB, because FIB, what do we do? Normally you have the prefix, and also you have the next hop groups. Then you're converting next hop group to a bunch of the other like objects into the hardware. But we don't need the prefix handling or the majority part. The reason is that today SONiC is using the Linux as a slow pass. So that's why like that's different from traditional like say NOS, which you need to handle both slow pass and fast pass. So I only need to do handling the fast pass in SONiC. Then which means that most of the route handling could be just pass through. The only thing which we'll do is just converting the ID. Then the only thing is like say the main goal is like say we want to convert whatever the next hop group information into the zebra to the different object into the SONiC. Here, like I was mentioning, like say the different object, because this is not the next hop group to next hop group mapping. It will be mapping to the different object based on the use cases. So that's why we're introducing, like I say, the first thing is that you want to do is like say, we get all the informations. Whatever the information we get from the zebra, we get it and store in the SONiC zebra NH table. So you can mimic, logically you can consider, this will be the same, exactly the mapping between the zebra down to the SONiC. So that means that we would be able to get all the needed information. That's what the agreement from the FR community. Whatever the information we get, they will provide it. So that's all the information. The second part is that we may need to create our own next hop group information, which I will discuss in the afternoon. But that we call the SONiC NH table. There are some object we would create it. Then we also need to have like a ID managing, because we need to have our own ID. That's the reason, because warm reboot, we try to see let the zebra to take persistence on the next hop ID, but they won't be able to do it. They feel this is a data claim requirement. That's why
Yeah.
SONiC should have to do it.
And the reconciliation of the next group ID was not possible.
Yeah. That's because you cannot use the kernel to be coming back for that. So that's the main thing. Then we also have, like I say, for warm reboot, you need to keep all the information because you basically want to mapping the previously Zebra ID to the new ID. So that's the main thing. Then we also have some, like I say, helping functions. So this is a like high level. We could like say within that FIB manager, we only have like say these 5 blocks will be getting involved.
One thing is also I just want to add for Eddie is like why we currently the proposal is to put it as part of the FPM is to avoid the number of time that we are going to write into FPB.
Yeah.
Because otherwise we're always going to go to that, come back, go to. I mean, how can you be fast?
Yeah.
You start doing that. So how can we streamline more the download of routes and SONiC? That's what also we're trying to achieve. Yeah. So maybe there's a better place to do it, but for now, that's what we are thinking of. And also, we don't want to change the entire world because it will never happen.
Yeah, and also that will go back to the previous the ARS one, like a Jeff and think about this one because previously you don't want to go to the Zebra because it's up to changing it. That's why you put the code into the auth agent. Now we have the FIB. You could change it. Now, and also it's better. The reason is like the moment you change it, then in the FDB, we get a final one. So it's even better for debugging purpose. That one, I would like to have a separate discussion in the working group with the ARS folks to see that can we consolidate these thoughts. So today, I haven't put the ARS into my like HLD, but we can discuss it in the working group. So then we're talking about like say roughly what happened on the FR side. We get a good support from the FR side also. So they basically say they will logically, like I say today, everything is using the Zebra D plan context. They will collecting everything, then give to the D plan. D plan today we converting into SONiC code is converting the D plan context into the SONiC object. But we will not convert into SONiC object. We will take whatever in the D plan context and give to the FPM syncd. Then let the FPM syncd to do or whatever the extra logic will be on it. So then they will basically say the only difference is like they will give like I say currently we call it unresolved energy basically, or you can consider the original energy. So for each of the prefix or context, they will give you a resolved one, which is currently we have, and the original one, which is which come from your particle, which we can discuss later on. So we need both of the information, and also we were introducing the resolve through, resolve why this concept. Basically, say we basically want to build the dependency chain for the recursive purpose. You have the next hop group over next hop group, then over next hop group. Then we want to build a dependency. Then we can do the forward walk, back walk when we're resolving the dependencies. So that's the main reason. Then we also want to get the trigger to say once we have outage, we want to know that where we get outage, and we want to. So that's the 3 main things, like come from the FR side. On the phase 2, the FR side will also want to say, I try to not changing the next hop group ID today. Next hop group ID will be changing whenever there is a change, right? Because nobody cares on that. They also want to say if they can avoid the unnecessary route. That's how group ID change. Then we don't need to flushing the routes because the moment you change the ID, we have to update the routes. So that's the main thing. So then from the SONiC side, we have like I don't need to go to it, but basically say I just show you like there's 5 blocks. So we want to put that in, and roughly 2 of my team members were right now working on it. So we're working on the SONiC side. So this is roughly the developer plan on it. Then for the call for action, in the afternoon, we too will be hosting the routing working group meetup. So let's discuss. We only have 30 minutes. It was like 1 hour, but it's shortened to 30 minutes. So,
but also you can come at the SONiC routing work group every Thursday. So you're welcome to attend, right? So so that's probably one of the good subjects that we are talking there.
And the HOD, the PR is already out, so everybody are welcome to get the comments. So we want to like get this one once done for all to get this done. Yeah. Okay.
Quick note also, it's everything about failure detection because convergence are not being in scope right now. So this is something that you want to help on a separate train. You're welcome.
Okay, thanks.
Thank you.
Mhm.
Question.
So while we are talking about next stop groups, so there's an attribute called hierarchical next stop.
Mhm.
So are you guys planning support in SONiC to start using those attributes?
Not at this moment. I see where you're going. So it will be helping for convergence because the hardware
Not just
you.
convergence, also because as you know, I'm from Cisco.
Yeah.
We have next stop groups at
Yes.
different levels and
Yeah.
stuff, right? So so today we have a tough job
Agree.
creating what kind of next stop group to use, and hierarchical will tell you whether this particular next stop is going to be used for tunnels or whether it's going to be used for regular IP. So
That one we already have. We have the type there. So I was thinking there another way, like say, for example, you have like say recursive routes that will helping for convergence. But the type we already have today. So we know that say this is the VXLAN next hop group ID, or this is the SRv6 next hop group ID. That one information as of today we have it. Yeah. But I see your point where you're going. It's like I want to go there because the hardware supporting multi-levels. So it will be helping to go with like say mimic like exactly the software object. Today we do the clapping everything together. So the moment you have an outage, your backwalk will be trigger a lot of update. Yeah.
Other questions?
Did you had a chance to measure the footprint of having yet another cache in FPM SIMD?
PM, what do you mean the cache?
So you are storing all information
Oh,
from
I see,
Zebra
I
now.
see.
So how big it can be?
So
And-
that's a good question.
I don't know.
And,
Personally, I don't know. We didn't do it.
I didn't do that, but think about it this way. Normally, the worry about, because that's my previous experience. Normally, I worry about the routes footprint because that take go millions. That's how group doesn't take that many. It's in the like 1,000 level, like
And most
10,000 to 20,000.
And most likely we're gonna move the footprint from route arch to FPM SIMD.
Yeah.
I mean,
So from
that's a good question though.
yeah, but we haven't done the measurement, but I don't expecting it's a major shortage, like the drawback. Because if it is the route, I will worry about it. But if
Okay.
the next hop, I never worry about it.
Okay, thank you.
Yeah, I have a quick question.
Mhm.
So with the recent AI in deployments, we see higher scale numbers for ECMP, right? 128 by ECMP, 256 by ECMP.
Mhm.
With the new design, is there any new thing you are bringing up to improve the next up group update? That's my first question. The second question is, some of the next up group is owned by the layer 3 protocols like BGP. If the L3 next up group is created by BGP, it is BGPD responsibility to remove it, right? So, with the type 5 route withdraw, it removes the next up, right? So like when you convert
I can take both.
when you convert it into two pieces, how does it converge in a scale?
Okay. I try to answer the first one. The first one, I need to supporting the 256 anyway. So there are two parts. One is like I said today, Zebra clapping everything to be the 256. That one, ideally, it's better to using the recursive because I do have the use case that like I have like 16 pass over another 16 pass. Flattening over, I get a 256 ECMP, which I don't like it. But today, anyway, I have to take it. Right, so that's one. So the short answer is I don't plan to make any change in that area. Whatever the Zebra told me to do, I'm doing it.
And I think Zebra has been extended to 512 now, right?
512, yeah, that's good for the Microsoft.
I think I'm not sure if the code has been committed. But
It is there. It
It
is
is
there.
there?
I see that. Then the second question is like Zebra is the source of truth. BGP gives this everything to Zebra. So we are the slave on Zebra, not on the BGP. So all next hop group is determined by the BGP, not by the Zebra.
So there's an example.
No, not really. So if it is created by BGPD, it's the BGPD.
BGPT will give to the Zebra.
Right.
Eventually, Zebra will give to the D-plan. So that's why I would say, like from the D-plan point of view, Zebra is the source of truth.
And if failure or path are changing, the whole idea is the SONiC can make his own decisions super fast. And then the control plane will come as a slow download and make sure what the decision that SONiC has done as a fast decision will be consistent. right?
But-
It's always like your fast pass and super bad support.
But isn't it that like it will that it will increase the convergence, right? Like, I mean,
Why?
it
No,
won't benefit it. Like,
No,
No, because
convergence is based on the loss of the traffic. So the loss of traffic will be shorted. But you take time for the calculate. That's fine. That's what all the OS not doing.